So in this section, we are introducing logic. So to do that, we're going to talk about statements, quantifiers, and truth tables. So with this statement, if it's Thanksgiving, then we will have a turkey dinner. Today is not Thanksgiving, therefore we'll not have turkey for dinner. What about this argument? So this basically, we could still have turkey, right? Just because so it being Thanksgiving implies that we will have turkey, but it not being Thanksgiving doesn't necessarily imply that we won't. And we'll talk more about why that is true or not true later on. So the goal of this whole section is to talk about the truth or falsehood of statements and the validity of arguments. So some definitions. A declarative sentence, that's something that is either true or false, but not both. So some examples: my name is Emily. I teach math at CSU. Statements, either, they're both actually true statements, right? Okay, so here are some that are not statements. Do your homework. That's a command. That's not a statement. Are you bored? That's a question. Oklahoma State is the best Big 12 school. That's an opinion. That would be my husband's opinion. And that would be true or false depending on who you are. This sentence is false. Ugh. So if we say that that's true, then the sentence itself is false. If we say it's false, then the sentence is true. This is confusing. And it can't be both true and false. So it's not a statement. Okay. Another thing that we do is we use words to connect statements, so and, or not. With and, you can think about this like in the set stuff we just did, like an intersection, or would be like a union, the things that are in A or in B. And then not, you can think about that like the complement, but we'll talk more about that in a minute. So we are going to, in this, so these are component statements together making a compound statement. So we are going to circle the connectives that make these compound statements and then identify the components. So the connector here is or. So frogs are amphibians is one of the statements. Another one of the statements is that the iPhone 7 is edible. Okay. Today is not a Friday. So the connector or would be the not there. So the statement itself that has been modified is today is Friday. And then for C, jaywalking is safe and speeding is not a crime. The connector is and. So jaywalking is safe. And speeding, actually not there. Speeding is a crime. Okay. So we have this table here where and is given to us by this symbol that looks a whole lot like the intersection symbol, right? Yes. And then we have the or symbol, which looks a lot like a union, and then the negation. So, or the opposite. So what we're going to do, we're going to look back at these three examples, A, B, and C, and we're going to label each component statement with a lowercase letter. So let's do the screen. The iPhone 7 is edible. How about an E for edible? Today is Friday. Let's go with the T, so it's not the same as the one above that. Now let's do an F. This will be fine. Today is Friday. Good. Jaywalking is safe. Let's go with a J. Speeding is a crime. Let's go with S. Okay, we've labeled each compound statement with a lowercase letter, and that's a thing that each component statement with a lowercase letter. And now we want to use the notation from this table to translate the sentence into symbols. So frogs are amphibians, or the iPhone 7 is edible. So frogs are amphibians, or the iPhone 7 is edible, using the or. Okay, today is not a Friday. So we've got today is Friday, and then the negation of that today is not a Friday. And then for C, jaywalking is safe. Speeding is not a crime. So jaywalking is safe and speeding is not a crime. So this you would read F or E, not F. And this would be J and not S. So in class, we will go through more of this, but I wanted